So now let's talk about pH of solution. What does pH means? pH means it is potential of hydrogen. Potential of hydrogen. Potential of hydrogen. Now let's see further. pH mathematically it is defined as minus log of active mass of H plus. This is minus log of active mass of H plus. So what does active mass of H plus means? Active mass means where H plus is, that it is active mass of H plus. Now what does active mass mean? Active mass means active mass equals to activity coefficient which is denoted by gamma multiplied by molar mass. Okay, molar mass. Okay, so this is known as active mass, that is H plus. Okay, activity coefficient into molar mass. In general, activity coefficient is taken as 1 in general. Okay, activity coefficient is taken as 1 and now it is molar mass. So pH of a solution is defined only for dilute solution. pH of solution is defined only for dilute solution. It is defined only for dilute solution. So now let's take an example. If we have a concentrated solution, like example, pH of 10 to the power 2 molar HCl. Now it is not a dilute solution. Okay, so it is concentrated solution. So pH equals to 10 to the power 2 molar HCl. Now we have to take the activity. Activity is defined as active mass of H plus gamma into molar mass of H plus. Okay, gamma into concentration of H plus. So concentration of H plus is given by 10 to the power 2. Now in that case gamma will become 1 by 1000 and it is 1000. So concentration of H plus is 1. Now pH will become 0. So there is no significance of pH in concentrated solution. No significance of pH in concentrated solution. Okay, here the activity coefficient will become inverse to the molar mass. Okay, this is now activity coefficient. Now let's talk about pH of water now. pH of water. And now we talk about it. Room temperature at 25 degrees Celsius. Concentration of H plus, it is 10 to the power minus 7. The concentration is 10 to the power minus 7. So pH is given by 7. So pH is 7. Now as temperature, as we increase the temperature, as temperature increases, concentration of H plus increases and pH decreases. No, as temperature increases, concentration of H plus increases and pH decreases. Now when pH decreases, that is pH of cold water. Now that is, it is the pH of cold water. as at 25 degrees Celsius, as H plus is 10 to the minus 7, pH is 7. As temperature increases, H plus increases. Now pH decreases. So that means pH of cold water is greater than pH of pH of hot water. That means pH of cold water is greater than pH of hot water at particular temperature. Now we know Kw is H plus into OH minus. Now log Kw, it is log H plus log OH minus. Now that is pH. Now pH equals to, now here we can pKw. Now we can, if we multiply everywhere with the negative sign, here if we multiply everywhere with negative sign, so minus log W, log Kw equals to minus log H plus minus log of OH minus. So pKw, it is pKw equals to pH plus POH. So this is defined as pH plus POH. This is ionic constant of water. Now at 25 degrees Celsius, that is equals to 14. At 25 degrees Celsius, at 25 degrees Celsius, pKw equals to 14. Now let's say further pH scale. pH scale. Now pH scale varies from 0 to 14 in at 25 degrees Celsius. So pH 7, it is a neutral. It is basic. It is acidic. Neutral, basic, and acidic. Now we know Kw. Now if someone is asked if it is been asked what is Kw, if Kw equals to 10 to the power minus 12 at 40 degrees Celsius. Now what is the nature of that? What will be the nature of 5 into 10 to the power minus 7 molar H plus? What will be the nature of this concentration? So Kw is 10 to the power minus 12. Now we know pH scale. If we try to draw pH scale for that 40 degrees Celsius, then it will be varying from 0 to 12. Now at 6 it will be neutral. Okay, now it is acidic. Now it is basic. It is acidic and this is basic. So it is neutral from 0 to 12. Now we know if we try to take minus log H plus, so that is minus log 5 into 10 to the power minus 7. That is 7 minus log 5. That comes out to be 6.3. So we know as we go beyond 6.3, it is a basic in nature. Basic in nature. Now let's start talking about pH of strong acid. pH of strong acid. pH of strong acid. Now we know that we can only calculate the pH only in case of dilute solution, not in concentrated solution. When the solution is concentrated, we have seen the activity coefficient become inverse to the molar concentration, then it gets 1 and pH becomes 0. Now when strong acid is diluted, now let's take first example. Let's 10 to the power minus 3 molar H2SO4. What will be the pH? Now we know when it is when we call strong acid, We call it as a strong acid when alpha is 1, means it is 100% dissociated. Alpha is 1 means it is 100% dissociated. Now we know it is 10 to the power minus 3 H2SO4. Now we know that H2SO4 will converting to 2H plus SO4 minus 2. So T equals to 0. We have 10 to the power minus 3 concentration. And when the reaction completed, it becomes 0. It becomes 2 into 10 to the power minus 3, and it becomes 10 to the power minus 3. So pH comes out to be minus log of H plus. What is H plus concentration here? Here it is minus log. Here now we have to take gamma 1 when it is a dilute solution. Okay, gamma equals to 1 when dilute solution is there. That we have to consider gamma, until unless if it is a not a dilute concentration solution, and gamma is inverse to the molar concentration. Now gamma is when the solution is dilute. When nothing is given, we will take the gamma is 1 for dilute solution. So it is 2 into 10 to the power minus 3. So it is 3 minus log 2. So it is 2.7. The pH is 2.7. Now let's take a second case when normality is given. So normality, in case of normality, if we have given 10 to the power minus 3 normal H2SO4. So here if we consider again H2SO4 10 to the power minus 3 molar, 3 normal, then we know that it is molarity. We have to check their molarity. Molarity equals to normality into n factor. Okay, molarity equals to, now molarity equals to normality into n factor. When it is 10 to the power minus 3 normal H2SO4, then what will be the molarity? Molarity will be 10 to the power minus 3 divided by 2 will be that molar solution, that is molarity. Okay, if we talk about concentration of H plus, or we can talk about concentration of H2SO4, that is 10 to the power minus 3 divided by 2 molar solution. Now in that solution, what will be the concentration of H plus? Now again, if we consider this reaction, H2SO4 gives 2H plus plus SO4 minus 2. So it is 10 to the power minus 3 divided by 2. T equals to 0. When the reaction ended, it becomes 2 into 10 to the power minus 3 divided by 2. So again, gamma we will take as a 1. So pH equals to minus log H plus, means pH will be equals to minus log 10 to the power minus 3. Okay, it will cancel and remaining. So 3 will be the pH in that case.